So in this video, we are going to make our own version of a Knobster. Now, I had this kicking around from a video that I did before about making this knob work with the standard Garmin trainer. I did this for the GNS 480 group because, well, we need to use our GNS trainer. It's not like we can put that in the sim. So anyway, if you want to see how I physically made this, head on over to this other video that should be linked now to learn how to do it. Basically, it's a plastic project box. We drilled a hole in it. We mounted the dual concentric knob, which I got from Prop Wash. You can get Elm ones. There's lots to choose from. And then inside, we've got an Arduino Pro Micro. Now, we're going to show different code in this one, which is also linked down below, which you'll be able to download, as well as the schematic for the wiring. That way you can wire it up, solder it up, load the code, and you'll be good to go with the joystick library. First half is using this. The second half, which came from one of the members in the Discord group, was, hey, can we use a StreamDeck to emulate kind of how they do it with a Knobster? So what we're going to do is we're going to take our StreamDeck, we're going to assign buttons that will let us repurpose what the knob is controlling. So whether it be heading, altitude, IAS speed, or even COM and nav audio radios, we can map those to our knob. So let's go ahead, jump into the sim, and see how we did it.
For this one, why not? Let's use the CJ4 with the working title mod. It's also going to let us throw in some H events, some LVARs, as well as the local variables that we're going to play with. So here we are in SPAD.neXt, and you'll see that our Arduino is already discovered. Now, I did come over to device settings, and I renamed the device the SPADster. Why not have a little fun with where the idea is coming from? Now, right away, you're going to see, wow, it shows up as a 5-button joystick. If you look at the schematic, you're going to see it is very straightforward. We are connecting a bunch of pins up to the encoder. Jump into our Arduino code real quick. You'll see that it's a dual concentric knob. And again, we've got the image linked along with the code. So you'll be able just to grab all this, as well as the schematic for wiring it up. But essentially, a dual concentric encoder is the equivalent of 2 rotary encoders with a single push button. And the encoders have a pair of pins for one encoder and a second pair. And so on the Arduino, we've got the first encoder pair connected to pins 1 and pin 0. And then we've got the second one connected to pins 2 and 3. Now there are some grounds or commons, and we connect those to ground, or we connect them together and only one of them to ground. Finally, the button has its own pin, and I chose pin 15. It's important to know we need the Arduino joystick library. So if you haven't already gotten this and used this, head on over to this link, and that's going to get you the joystick library. As always, I want to thank Ben Buxton. He wrote the perfect Arduino rotary encoder code, and it by far is better than anything in any other library, and you just put the code directly in your sketch. So first up, we're going to include joystick.h so that we can have our joystick functions. Now, the prop wash encoders run as half step, so they're defined as half step. Comment this out, meaning put your cursor here and comment it out with 2 slashes if you want the full step or non-half step. Now, our joystick does have rotaries and it does have pull-ups. What pull-up means is for all these pins, we're tying them high or pulling them up from ground, and then we're using ground to short them. So we enable pull-ups, so it automatically sets that for us. We're going to define that we have 2 rotaries and a total of 5 buttons. We're going to set up our structure for rotary defined. So we got our first byte is pin 1, our second byte is pin 2. Then our next item in the structure is the clockwise character, and that's what's going to get put into the button, is the character. And then we've got our clockwise character. And then volatile unsigned character is state. So now we're going to define our rotaries. So rotaries definition, set rotaries. So rotaries is num of rotaries. So that went up there. So here, pin 0 for the first one, pin 1 for the first one, and then it's going to get linked to button 0, because remember, everything in code starts at 0. So button 1 actually is button 0. And then the other one will go to pin 1, and default is 0. And then we got 2 and 3 going to 2 and 3. Nice and simple, default is 0. So defining direction clockwise starts at 0x10. This isn't really important, but it's, if you care, I've done other videos that explain it. So basically, this is going to figure out all of the steps of the rotary encoders and how we're defining it. And that's what Ben Buxton did, and it's freaking awesome. Next up, constrained unsigned characters. Again, this is filling in the table for when it calculates the code, what each thing is, begins, final, starts. So again, that's all part of that code, and if ends it. So now we are going to initialize the joystick. So joystick underscore joystick, joystick default report ID. So this is going to use the default reporting ID. There are other videos explaining how you can change the default reporting ID, so you can do this every time you compile the sketch. That way you can make multiple different ones that won't show up. Now what's great is SPAD will enumerate them. So once you get them set up and you have them plugged into the same USB ports, they'll never disappear on you again. So this joystick is going to have 5 buttons, no axes, and all my axes are set to false. So when we go to set up, well, we want to set our pin mode for button 15. That's going to be an input pull-up. And we're going to then joystick begin. So it'll fire off the launch of the joystick. And we're going to run that rotary init from above. And again, this is automatically going to initialize the rotaries and pull those pins low and do a pull-up. On our loop, we are going to check all encoders and we're going to check all buttons. It's going to run the functions. Then we have no delay. This was put in so you can test your code. We need no delay as it wraps around and runs these functions. So our function for check all buttons, well, we've only got the one button set up. So joystick.setButton, it's going to set button 4, which is button 5, right? Because remember, 0 base, based on reading digital pin 15. So if it's low, that means the button has been pressed. Check all encoders, that runs this for loop, which again is going to run through the rotaries one by one and check all of the directions. And if it checks a character, it's going to delay 50. So it's going to write the 1, delay 50, and then turn it off. So it's a 50 millisecond pulse for a button. So perfect for a joystick button press with an encoder, since encoders can't really get held. So you don't want it to be too long, because then it could register it as a button held versus a click. So 50 works out perfect. So that's it. That's all of our code. Once we've uploaded this sketch to our joystick, what we end up with is what you see here. So we would have relaunched SPAD.neXt. It's going to pick up this new human interface device, and it's got our 5 buttons. The first step of what we need to achieve is mapping the buttons so that we can make control selectors. We're going to first go into our defaults, and let's go ahead and let's put in some text. Vertical, we're going to put it towards the bottom, and that text will be good. All right, so that's going to be our heading knob. Let's just copy it. Let's go here. Let's paste it. Now that we got our buttons aligned with our top panel, we got course 1 to the knob, we got the VS pitch wheel, speed knob, heading knob, altitude knob, course 2 knob, and we're going to do a COM1, and later we're going to copy and paste COM1 to show us how that works. Now up first, what we want to do is make it so that these buttons are going to change the value of a local variable. So we want to add an event that when it's pressed short on this button, so we're going to add an action, and we want to change a data value. And so we're going to make a new local variable. And we're going to call this local variable knob mode. And it's going to be a number. And we're going to go ahead and just make it simple decimal. And the default value is going to be 0 or unassigned. And that'll be a good start. So what we want to change that data value to with this button press is we want to set it to a 1. So now we're going to be changing our knob mode to 1. So let's go ahead. Let's copy this event. Let's go here and let's paste it. Now we're going to go ahead and we're going to paste this into all of these remaining buttons. So through the magic of editing, poof, and we'll be done. Now that we pasted it everywhere, let's go ahead and let's change these to the next value. So the second button is going to go for a value of 2. And then we want to go for a value of 3, etc., until we get to the end of the list. So there you have it. 2, 3, 4, 5, 6, 7. One of the things we can also do, and this is where some of those nice looking buttons would make it look prettier and have the cool looks, but we can also add another event, and that's going to be that we're going to change the color. So we want to change the color for row 1, button 1, and it's going to go ahead and that plate, how's dark blue going to look? Let's find out. We want it to be permanent on, right? You could even have it flash once, flash for 2 seconds. We're going to go with permanent on. And the condition for that is going to be our new knob mode when it equals 1. So now we're going to go ahead and we're going to copy this, and we're going to go to each one of these, we're going to paste it, and we are going to change the knob mode to, well, match the mode we want to be in. All right, so let's jump ahead and whip through all of these. Now what we have to do is also set a reason why it needs to go off. So we're going to go ahead and we're going to set the state for which this button light should go out. So what I did was I took that, I hit copy this event, and then we hit paste. We got an extra one. We clicked on it, and now we're going to say when it is unequal to 1, we're going to change the color to off. And so that way it's tracking our knob mode, and when it changes, it'll have to think about it. So let's go ahead and do that for each one of these. We're going to have to copy just the one event, paste it, open it up, change it to unequal, and change from dark blue to off. Off. All right, so go ahead and do that for all of the buttons now. Now we can see as we select the buttons, so we have basically done what we need to do for picking what the knob is going to control. Back to the controls, and we're going to now start setting up the SPADster buttons. Now, one of the other things you can do is, if you want, you can make some global settings, and you can set what these are supposed to be. Now, these buttons, we're going to make them simple push buttons. So that's just because they're going to have the simple normal push button, as opposed to having switch state abilities, long holds, things like that. Button 5, which is the push button, we're going to go ahead and leave that as a full push button. So if we want to, we could set short modes and long modes on it if we so choose. So we're going to go ahead and we're going to leave that as is. Now, of course, SPAD.neXt needs to be restarted for this change to take effect. So let's go ahead, close it down, and relaunch it. Now that we've got our buttons ready to go, now what we want to do is start figuring out what we're doing for each one of those events. When we jump over and look at the working title autopilot, we're going to find out that it does have H events and it does have LVARs. We do know that the heading select is using autopilot heading lock direction 1, for example, and ISpeed VS selects. So there is data for us to work with when it comes to the data values for those. What you will see is course does not use anything custom. So for course, we're going to be able to leverage using the standard OBS. So let's go ahead and let's start off, and we're going to set up all of our inner clockwise modes. So let's go ahead, we're going to add an event, and we're going to go with button pressed, and pretty much that's all we're going to do for these. So this is where it gets kind of cool, is we're going to add a condition, we're going to select that knob mode that we created, and when the knob mode equals 1, now we're going to go ahead and we're going to add our action. So we're going to go with changing of data value, and in this case we're going to look for I believe it's OBS, so nav OBS 1. And so what's cool about nav OBS 1 is we're going to increment by 1 with the outer knob, or sorry, the inner knob, and then the outer knob, we're going to go ahead and we're going to change that to an increment of 10. And that way, if it's a big turn, we can use the outer knob, jump us 10 at a time, and for a smaller turn, we just use the inner knob. So, something to go with. Now, what's also really neat is we can go ahead and we can say, hey, you know, we've got a technically 1 through 360, but we'll say 0, max 360, and we will allow rollover. So when it gets up to 360, it's going to roll over to 0 for us. Hey, that's cool. So we're going to go ahead and we've got our first thing assigned. But I almost forgot. Button mode, normal. We do not want this rippling multiple triggers, though that was another way to create acceleration. If you spun it really quick, it's going to hit up really quick and you could fire off multiple events, but we don't want to do that. In the future, we're hoping we will have a leverage in here for acceleration like we have in some of the other panels. But what we do want to do, what we should do, is we should end processing after this event fires so it doesn't continue going down the list trying to check if any of the other events are valid. So it's kind of like a case statement. All right, so that's our first one. And as always, way easier to just copy this event. We're going to go ahead and we're going to paste it. And we are moving on. And the next item in our line is our VS wheel. Now, you can always head on over to your StreamDeck, which you can be staring at to make your life easier so you know which one it's going to be. So we're just saying, well, now let's do something when it's 2. And we're going to go ahead and we are going to increment the VS wheel. So if we look this time over at our list of events from working title, you see we want to be controlling autopilot vertical lock. In that case, what we want to be doing is the data value we want to go to Microsoft events, or data I should say, and we are looking for vertical. We're going to increment with our inner for a value of 100. Set some limits. We'll go with minus 10,000, and we'll go to positive 10,000, but no rollover. We got our vertical hold variable. We're going to adjust by 100. And yes, we want to end processing. Let's go ahead and let's copy this. Let's paste it. So next up is speed. And if we have a look at our working title speed, it's autopilot airspeed. So let's go ahead and session 3. And now, autopilot speed hold, airspeed hold variable 1. Now, we want to increment this with the inner. We'll go 1s. Limits, well, yeah, it's going to have a minimum of 0. And we're going to have a maximum 340. Why go above 340? We want to end processing. So now we've got that incrementing. I'm going to go hit save. Next up on our list is heading. So if we look over here and we look to their heading, autopilot heading lock, it's heading hold 0. So we're going to come in here. Let's take this guy. We're going to copy this event. Paste it. Session 4. Heading lock 1. Increment by 1. Limits. It's going to be, I guess it's technically 1, 2, 3, 6, 0. And we are going to allow rollover. So hit OK and yes. And this is really all you got to do. We're just copying, we're pasting, and we're moving on to number 5. And number 5 is our altitude. And now, if we check out over here, altitude lock variable 1. Altitude variable 1. We're going to, on this one, we're going to go with 100. Minimum is 0. And maximum, we're going to go ahead and, what is this plane? 41, 43, whatever. We'll say 49,000. And no rollover, so it'll get up to the top. So we're going to go ahead and do that. And yes, end processing. So now that we've got altitude done, the next one is gonna be course 2. That's the next knob for this. So we're just gonna simply come up here. We're gonna do a quick little copy of this event. We're gonna paste, And then, of course, we're going to hop in. We're going to throw down 6. Connect. And let's flip it to OBS2. We're going to increment by 1. Same thing. Probably should be a 1 to 360, but whatever. We're going to go ahead and we're going to build COM1 on here. We're going to copy this event. We're going to paste it. Going to change this to when it's session 7. What we want to do here is we don't want to change a data value for this. Going to add an action. And we want to send simulation event. And we're going to go COM radio fraction increase. COM1 is called COM, so we're going to do the fraction increase. So it's going to automatically clink, and again, same thing. So now we have our radio control. We're going to come over here, and we're going to copy all events. Not the complete device, all events that are on this button. And now let's go to button 2, and you can see the button 2 is my counterclockwise. And so we're going to come here, and we're going to paste, boom, puts them all in. So now life's real easy. We're just going to come in, we're going to change that to decrement, we're going to click OK, boom. And all we do is come down each one of these, and we change the function to decrement. So those are all changed to decrement, and now what we do with this is we do go into the event and we change it to the fraction decrease. Let's go back to button 1. We're going to copy all events, and we're now going to turn our outer knob and confirm that clockwise is using 3, counterclockwise is using 4. So let's go to 3. We're going to come in and we're going to hit paste. This is now the outer knob. So this is where we're saying, hey, let's give ourselves the ability on course to jump by 10 at a time. So we're going to change the outer knob. And then for our vertical speed, let's go ahead and let's use the outer knob to dial by 500s. Because 1,000, well, it'll be a lot more than we need. So we're going to dial up by 500. And then for our airspeed hold, let's go ahead and change that to 10 as well. So it's going to jump by 10s. We're going to come to our heading lock. Let's go ahead and throw that one to 10. Now for our altitude, the outer knob is going to be by the thousands for us. OBS2, let's go ahead and let's increment by 10. Now, when we get to our radio, well, the outer knob is the holes. So we're going to go ahead, we're going to change this from fraction increase, and we're going to change to whole increase. I'm going to click OK, and away we go. So that is all we have to do for this guy. And so now you have two choices. You could copy from button 2 to button 4 and then type in the extra values, or you can copy this and just change to a decrement. So for me, I'm going to copy all events. I'm going to go here. I'm going to paste. And now we're going to change these to a decrement event. You know, it's 6 of one, half dozen of the other. You could go either way. All right, let's jump it in. All right, so there you go. All of them set to decrement now, so go in the opposite direction for us. And then we're going to hop into our radio. And of course, that's now going to be the whole decrement. And just like that, we've got our knobs for our encoders all programmed for what we want to do. Now, if we look at the sim and we go back in and we see, now most of these knobs all have a push button feature. Plus, if you're on a COM knob, it's nice to have the button to toggle it. And since there's a push button on these knobs, let's go ahead and let's put in the buttons for all of these. We're going to go ahead and we're going to copy all events. We're going to go to button 5 and we are going to paste them. So let's go ahead, jump back straight into SPAD, since what we need to do now is when it's knob session 1, button mode pressed short. And so this is what's also cool, is all those were pressed short events, and we're implementing the pressed short. However, if we were to add event, you have pressed short, you have pressed long, you have button released. So when it's this button pressed, we're going to go ahead, we're going to delete this event. We can come in now and we can look at the H events. So you're going to see that there is a heading, an LNAV, an approach, a VNAV, a VS, a flight level change, a flight director, and an altitude selector as well. Now, for course, part of me wants to say that there is a button, but I can't remember. But that's where the beauty of SPAD.neXt comes in and helps us. Because when we go to send a simulation event, and we go to Microsoft 2020, we can go working title _, and it's going to nicely separate all those for us. And there is a course 1 pressed. However, that's a code event. So my guess is that may or may not work, but we're going to go ahead and we're going to throw it on because it's in the list. So let's see if it's going to work out for us. All right. So the next button, this is going to be the VS wheel. And instead of increment or decrement, we're going to go with set, and we're going to set it to 0. So that's going to automatically just set our vertical speed to 0 for us. So what do we want to do with the airspeed? Well, airspeed has a button. So on the speed knob, that's going to toggle it between IAS and Mach mode. Let's come in here and let's change this to a simulation event, autopilot, and there is a FLC pressed. That is it's not the knob. So I think it's FLC speed pressed. So that should be the speed button pressed, which is actually an LVAR event. I don't think they've listed all of their events. So we're going to go with AP speed pressed, which should be the speed knob, because you have speed increase, which are code events. So let's go ahead and let's just try to populate it. Heading. So we want the heading sync button. So again, delete action, add action, send simulation event, AP, heading sync. So that's, or heading pressed. But heading pressed is the heading button. We want the heading sync, which is the sync button. So we've got that one. And then we've got our altitude cancel. Altitude alert cancel. There would be altitude. So that's the push cancel. Okay. And then we've got course 2 is our next one. It does not look like the course 2 button, though, is got any events actually mapped to it. Rest on it for now. And then finally, when we come down here, it was already an event, and now what we want is we want our COM swap. COM radio standby swap. So first up, let's pick our, so we switch to nav mode. If we go to course, there is our course changing by 1s and now by 10s. Very cool. Now on our StreamDeck, we press the vertical pitch button. And so if we just take a quick look over there, you see that's now lit in blue. So vertical pitch wheel. And so now when we are controlling that, you'll see that there goes our vertical speed by the hundreds. And if we use the outer knob, there it goes by the 500s. Pretty cool. And then we've got it that it's going to stop at 10,000. And same thing going up the other way, maxes out at 10,000. 5,000 is probably more than enough. And it looks like actually the sim itself is going to tap out at 6,000. So we could easily just go in and modify that to be 6. But we'll worry about that another time. So let's go to our speed. And if we are in speed mode, so we would want to be in flight level change mode instead. Okay, let's go to our heading knob. And there's our heading knob. Outer knob moving by 10s. Inner knob by 1s and 0s. Then we're going to go to altitude. And for our altitude, so there we go. We got our altitude selector going up by and down by the hundreds. And then if we use the outer knob, we can go ahead and go by the thousands. Oh yeah, that's nice and quick. Up to 450 is the max that's coded. So we can always go in and alter those as well. For our COM, if we go to that last button, press COM1, there we go. We can see our events populating. And we can see everything changing for us. So now that we got all those things done, now one thing real quick to note is I quickly, through the magic of editing, stopped recording and then fixed the airspeed hold. So airspeed hold is the only one that uses the legacy SimConnect value. So the SimConnect, not Microsoft Flight Sim, airspeed hold variable. That's the one that we needed assigned. So the speed pressed is working. If we go to our heading knob, right? Hey, look, the heading sync works. We need to publish this so that people can find it. So I'm going to go ahead. I'm going to throw it out there as the Microsoft Flight Sim Arduino SPADster example. All right, so this will be for the Arduino device. We're going to do the complete device. We're only going to do the CJ4 since it makes sense. Of course, you can override it. So now that we've published this guy, of course, once you have yours set up, plugged in, you want to just copy this down, click on any button, go to online snippets. You're going to want to look for the Arduino Micro, the complete device, and you're looking for me. Now, if you're not in the CJ4 and you just want to take it, copy it so you can modify the events, don't forget to uncheck the only for current aircraft and you will find it. Worst case, go all devices, search for me, scroll through the list. You're looking for the Arduino SPADster example. So that's what you put on this device. We're also going to head over to the StreamDeck, and it's a very rudimentary StreamDeck example. Obviously, we can make it much prettier, but this is, again, something for a very basic, get you going and playing with it. So we're going to go ahead and we are going to publish this device as well. All right, so we want the complete device again. Same thing, we're only going to do it for the CJ4. Again, as always, if you have it, you want to download it and play with it, you go to online snippets, and again, you can go to StreamDeck, complete device, and you've got that only for current aircraft. If you uncheck it, you'll see way more. So for on this one, you're going to see StreamDeck, XL, SPADster, example, less so Riley. And that way you can just pull in those pages and away you go. That looks like a good spot to stop it here. Don't forget, check out that other video if you're not sure how to just take a project box and drill out a hole to mount and solder those cables. You can find everything that you need there. Hit us up inside of the Discord if you need some other help. And if you could, go ahead, smash that like button, subscribe if you haven't, and come along with us next time. As always, thanks for watching. Have a great day.